Morning, guys. Today we are going to be looking at cyclic hydrocarbons and aromatics. So while it may seem like two different categories, really aromatics are just a special kind of cyclic hydrocarbons. So if I was going to define a cyclic hydrocarbon, I would say that they're hydrocarbons that form ring structures. You can have cyclic hydrocarbons for alkanes, also enes and ines. Just know that all cyclic hydrocarbons tend to be rare and are usually unstable. So while we're really going to focus on them today, the amount of time that we spend on them is really disproportionate compared to how much you find them in nature. With cyclic hydrocarbons, you're no longer looking at an ending necessarily, but we're looking at a prefix. So what that means is you can have an ene ending, you can have an ane ending. Your ending is still going to denote whether or not you have a single, double, or triple bond. To say that it's in a circular shape, we are actually going to use a prefix, and we're going to use the prefix cyclo. So cycloprop describes that there's three carbons in a circular shape. Cyclobute describes that there's four carbons in a circular shape. The general formula that you see listed a lot of the time is CnH2n, meaning that you have double the number of hydrogens to figure out the empirical formula. Just know that this actually applies to cyclic alkanes, which is what you're going to see most. It doesn't apply to enes and ines. Let's take a look at naming. Remember, naming is typically harder than drawing. Naming always starts with the same step, and it's the base number of carbons. So it's still going to be your longest continuous carbon chain. The difference here is that your base number of carbons might be your straight chain, or your base number of carbons might be your circular or your ring structure. So that's the first thing you need to decide. How you decide that is just by counting carbons. So if the ring actually has fewer carbons in the straight chain, then the straight chain is considered to be a base, and you're going to name the circular structure as a side chain. If the ring has more carbons, then the ring is the base, and you are going to name the straight chain as a side chain. You're going to pick your appropriate ending. Most of the time, you're going to see ane as your ending. However, you could see ene or ine. If the ring is the main structure, you're going to use cyclo directly in front of that base chain. So for example, 4 carbons in a row, cyclobute, and then either ane, ene, or ine, depending on the number of bonds that have formed. Name any additional side chains that you would in a regular hydrocarbon. The only difference now is that you can technically have cyclo as a side chain. So if your ring structure is not your main chain, if your ring structure is a side chain, you're going to use that word cyclo still, and you're still going to use that YL as an ending, as a suffix, to tell me it's a side chain. So for example, if you have a 3-carbon ring structure as a side chain, cyclo-prop-ul. Cyclo meaning circular, prop meaning 3 carbons, and ul, YL, meaning that it's a side chain. One thing that's different is the counting. If your ring structure is your main chain, what's carbon 1? Because technically you don't have a definitive beginning and end, you have a circle. That means you can pick anything in the circular shape to be carbon 1. This comes into play when you're naming anything that's a circular shape that has an ene or an ine ending, because remember your double bond and your triple bond is going to be the most important. So since we assume that your double bond or your triple bond is going to be on carbon 1, you don't actually have to list it in the name. Sounds confusing, but it actually makes things easier when naming. Let's take a look at a nice simple example to start to show us this rule. So first of all, I see a circular shape. I don't see a straight chain, so therefore I know my circular shape must be my main chain. I count my number of carbons, 1, 2, 3, 4, 5, 6. I have 6 carbons in a circular shape, cyclo-hex. I now see that I have a double bond. Now again, anything here can be carbon 1. This can be carbon 1, this can be carbon 1, but my double bond is the most important. So I'm actually going to make carbon 1 be my carbon that my double bond is 1. Since you're always going to do this, this is a rule, you don't actually have to list it as cyclo-hex-1-ene. We take a shortcut and we go ahead and assume that it's cyclo-hex-ene. Let's take a look at a couple other naming examples. We're actually going to do 2 for this until we get better practice I think I'm getting worse at drawing, but that's okay. Let's get my pen here. Yep. And we're going to take a look. Oh, that was scary. We're going to take a look at this structure to start. So I see that I do have straight chains, and I actually have a circular chain. Now, before we get too far, take a look at the shortcut that most chemists take. Here, this is actually considered to be a cyclic alkane in condensed formula. So notice that I didn't list individual carbons on the circle. Typically, in condensed formula, when you're dealing with cyclic hydrocarbons, you're going to see most chemists take the shortcut and actually use the line structure for the ring shape. Just saves you a little bit of time. So this here is my ring shape. I count 5 corners, 1, 2, 3, 4, 5. So this is going to be a pent. I don't see any double bonds, so this is actually going to be a pent-ane. I've got that circular shape, so I'm going to put the term cyclo out in front here. Squeeze that O in there. So this is now cyclopentane. That describes this circular shape here. I know my circular shape is actually my main chain because there's 5 carbons in my circular shape and there's only single carbons in my side chains. So these 2 straight chains here would be considered to be side chains. If I take a look, I see that they actually have single carbons in each of them. So I'm going to call that meth. And my 2 letters to denote that it's a side chain is ugh. Thought a mouse would be easier, maybe not. So I have methyl cyclopentane. I have 2 of these, so I'm going to use di. And I do have to state the location of my 2 methyl side chains. So remember, I can make anything carbon 1. I can also count clockwise, or I can count counterclockwise. So I can make this carbon 1, or I could make this carbon 1. Let's start by making this carbon 1. 1, 2, 3, 4, 5. So that would make this 1. I'm going to write up here for now. I'll do a good copy of this in a second. 1, comma, 3, dash, dimethyl cyclopentane. Or let's try to make this carbon 1, but count counterclockwise. 1, 2, 3, 4. That's actually bigger, so we don't want to go that way. What happens if I make this carbon 1 and count clockwise? 1, 2, 3, 4. So still bigger. What happens if I make this carbon 1 and count the other way? 1, 2, 3. It actually ends up being the same. So we were right the first time with 1, 3 dimethyl cyclopentane, but you do want to try counting both clockwise and counterclockwise just to determine that you are correct. Let's type this out because I realize that is super messy. So 1, 3 dimethyl cyclopentane. They just keep getting longer as we go in. And that would be the name for this one here. Okay, let's do the next one. So I do have a second example here. If you see, it's actually in line structure. So we're going to try to get to line structure instead. It is much easier. I can see that my straight chain in this case is actually longer than my circle here. So my straight chain is going to be my main chain. If I count my carbons in my straight chain, 1, 2, 3, 4, 5, 6. I've got, in this case, a hex. So I'm going to call this hex. They're all attached by single bonds. So we're actually going to call this hex-ane for single bonds. I have a side chain here. My side chain is 3 carbons. 1, 2, 3. This line here just represents the bond between this carbon in the main chain and this carbon in the side chain here. So we do have 3 carbons. That's going to be a prop. And remember, this is a side chain, so it's actually going to be a prop. Oh, that prop is in a circular shape, so we have to add a cyclo in front of it. And then this circular shape is going to be coming off of, well, we have 2 options. We can start counting from this end, or we can start counting from this end. If I start from this end, 1, 2, 3, 4, 5, it'd be carbon 5. But if I start counting from this end, it's actually carbon 2. So we would call this 2-cyclopropylhexane. Let's go back and let's take a look at how to draw these cyclic hydrocarbons. So notice the instructions are smaller because drawing tends to be easier. You always start by drawing the base chain. That's indicated by the number, the prefix in front of your ending. You're going to add any double or triple bonds. You're going to add any side chains. And then at the end, we're always going to go through and saturate. Now remember, you don't have to saturate that ring structure. We tend to use line structure, so you can assume that your ring structure is saturated. So let's try to visualize this one to start. I see octane as my ending. So with octane being my ending, that's going to be 8 carbons in a row. I then see 4 cyclopentyl. Well, this pentyl here, let's get a different color. This YL ending here tells me it's a side chain, and it's a side chain of how many carbons? It's a side chain of 5 carbons. This is a side chain because pent means 5, oct means 8, oct, 8 has more carbons. Those 5 carbons are organized in a circular manner, and that's coming off of carbon 4. So let's see what this is going to look like. I'm going to have my circular 5 carbon structure coming off as a side chain. Again, see that I've used just the line format, even though this is condensed. And then I have 8 carbons in a row. 1, 2, 3, 4, 5, 6, 7, 8. And this one here is coming off of carbon 4. Let's try another example. Let's take a look, and we are going to draw together 1,2-dimethylbutane. So I see this butane ending. So but means that I'm going to have 4 carbons in a circular shape. Honestly, part of the hardest part of this is figuring out what these shapes are going to look like. So if I have 4 carbons in a circular shape, it's going to look like a diamond or a square. Dimethyl, that means I have 2 single carbon side chains, and they're coming off of carbon 1 and carbon 2. Now remember, I can make any of these carbon 1. I'm actually going to make this top one carbon 1. You can choose to make it whatever you want. And I'm going to put a single carbon side chain coming off of that. And then I now have the option to count clockwise or to count counterclockwise. I'm going to go with, hi buddy, I'm going to go with clockwise. So I'm going to go with a single carbon side chain here. Last thing I need to do is go through and saturate. Remember, I don't have to saturate my ring structure. I just have to saturate my side chains. So this one here only has 1 bond. It's going to want to have 3 carbons. This one here only has 1 bond, so it is also going to want to have 3 carbons. Let's take a look at our next example, and our next example is going to be that specialized one that I talked about before. It's going to be aromatics. So aromatics are just a really fancy word for one particular type of cyclic hydrocarbon. So aromatics are very specifically talking about this structure called benzene. Benzene is very specific. It has 6 bonding electrons shared equally. So essentially a benzene structure is going to be 6 carbons, 3 double bonds always. The 3 double bonds in benzene are very specific where they actually alternate structure. So you have 3 different ways that you can represent benzene. In this class, we're always going to use resonant or hybrid structure. So the structural, let's look at what's happening here. I have my 6 carbons, but I've got these weird dotted lines here. What these dotted lines represent is the fact that those double bonds are alternating. We saw this before when we looked at coordinate covalent bonds before. So those double bonds are actually alternating between the carbons. I can represent that in my resonance structure here. So in my resonance structure, I've still got my 3 double bonds. Or my hybrid structure is probably the most popular. My hybrid structure is slightly more accurate than my resonant. Here it looks like the bonds are fixed, whereas in the hybrid structure, this circle represents that those bonds are actually moving. The general formula for benzene, C6H6. All right, drawing benzene or drawing aromatics, it's very similar to drawing circular, where you need to decide is benzene the root or is benzene a side chain. So if we have a straight chain with 6 or fewer carbons, then the root is going to be benzene. So if the straight chain has 5, 4, 3, 2, or 1 carbons, benzene is going to be the root. If the straight chain has more than 6 carbons, benzene is going to be a side chain. If it's a tie, 6 and 6, benzene wins. So if it's a tie, the equal numbers of carbons, benzene is going to be your root structure. Notice that the name benzene changes when it's a side chain. When benzene is the main event, when it's the base chain, you're using the base benzene. When benzene is a side chain, we're going to switch to using the term phenyl. It's still got a YL in it, so you can still tell that it's a side chain, but rather than calling it benzyl, kind of sounds weird, we're going to call it phenyl. You're going to use the appropriate IUPAC ending. This is only going to apply if benzene is a side chain. If benzene is in fact the main structure, you're always going to have that -ene ending in benzene. Remember, benzene has double bonds in it. Name any additional side chains that you might see, and remember that you are using phenyl if benzene is a side chain. Let's take a look at our first example. Our first example is here. So we've got this long straight chain, and we've also got this structure over here. So I'm going to count. I've got 1, 2, 3, 4, 5, 6, 7. This line here, this line right there that I'm highlighting right there, is actually a bond between this carbon and this carbon. So this main chain here actually only has 7. 7 in the straight chain outnumbers the 6 carbons that are in benzene, so we're going to call this heptane. Hept for 7, ane for the fact that they're all attached by single bonds. Since benzene is a side chain, we're going to call it phenyl. And what carbon is it coming off of? It's coming off of carbon 1. So 1-phenyl heptane. Let's take a look at another example. So we're going to take a look at this example here. This example, I can tell it's benzene, and it's benzene in my hybrid structure. My benzene ring is going to outnumber my side chains. I only have 2 carbons in a row here and 1 carbon in a row here. So my base name is going to be benzene. Remember, the suffix is built in here. Benzene, the ending is -ene to represent those double bonds. So benzene. I have 2 side chains. I have an F side chain and I have a meth side chain. Remember, I do want to list in alphabetical order. So we would go methyl. Oh, it's getting worse. Okay, let's try this again. Okay, maybe if I'm up here. I feel like this is, nope, still worse. I feel like this is really like class where I just need to be patient. Okay, slow it down. Let's try this again. Slight improvement. It only took 3 tries. There we go. Look at that spacing. All right, and then I am gonna have an ethyl group out in front here. Now let's talk about numbering. Remember, I can pick anything to be carbon 1. So I can pick this to be carbon 1, or I can pick this to carbon 1 to be carbon 1. Shouldn't matter, right? Technically, there is a correct answer here. If you have an option, so here I can make this carbon 1, or I can make this carbon 1. If you have an option, you always want to have your lower number to be in front. So since my ethyl group is in front, I'm actually going to make this my carbon 1, 1 ethyl. And then since my methyl group is coming second, I'm going to make that a 2, 2 methyl. 1 ethyl, 2 methyl, benzene would be the correct name for this. Let's look at drawing really quickly. So for drawing aromatics, we'll go back to yellow. For drawing aromatics, same idea, you always start with that base chain. I'm then going to draw my number of carbons as indicated by my prefix. This says to use resonance structure if benzene is a base. You can actually use hybrid structure. I'm going to use hybrid structure myself. So you can choose between resonant or hybrid. Do me a favor, don't use this structural just because you're going to make it so much harder on yourself. So either resonant or hybrid structure. At the end, you're going to add any indicated side chain. Our last step is always to saturate. However, remember this is just applying to side chains. So let's take a look at an example here. We have 1,3-dimethylbenzene. So I see benzene at the very end. We always read backwards. This implies that benzene is going to be that base. I see a methyl group. I actually see 2 methyl groups. So this YL tells me that it's a side chain, Dimethyl tells me that I have 2 single carbon side chains, and those single carbon side chains are on carbon 1 and they're on carbon 3. So what's this going to look like? I've got my benzene structure as my root, and I've noticed that I've used resonance structure. I have 2 single carbon side chains coming off of carbon 1 or carbon 3. You could have also made this carbon 1 and this carbon 3. It doesn't matter. It's the same structure. Last example that we'll try together. We're going to take a look at 2-phenyl octane. I'm actually going to try to draw just line structure for this to practice. So notice octane, that's my base. So I have 8 carbons in a row. So I'm going to draw it like this. I have 2, 3, 4, 5, 6, 7, 8. Those are my 8 carbons in a row. If you're not sure, count your corners. 1, 2, 3, 4, 5, 6, 7, 8. And this 2-phenyl, phenyl represents the fact that it's a benzene as a side chain, and 2 is coming off carbon 2. So I'm actually going to count in this direction. So I'm going to put my benzene here. And to draw benzene, I'm going to use my hybrid structure. So I have to have 6 sides. And my hybrid structure, I'm going to use that ring in the middle, 2-phenyl octane. Okay, so if you want to go through the additional materials, there is additional materials for this on our D2L site that allow you to practice it. And then that assignment that I gave you before the break also has cyclic hydrocarbons in it, so you can go ahead and practice that too. Tomorrow, really exciting, we get to start our haloalkanes and our alcohols. So we are starting our first hydrocarbon derivatives. Thank you for sticking with us, and we'll see you tomorrow. Bye.